Welcome to our second tutorial on theory of computation. So today we'll be learning about finite state automata and introduction to DFA. So let's get started. First thing, let's start with thought for the day. Push yourself because no one else is going to do it for you. So what are we going to learn today? First we'll look at what is finite automata, then what are types of finite automata, and then we'll learn about introduction to DFA. Alright. So what is finite automata? Finite automata is a language. Now when I say language, you know I am talking about contextual language. Okay. So finite automata is a language that has, first thing, finite number of states, and the control moves from state to state based on the external input. Okay. Now what do you mean by control moves from state to state based on the external input? We'll look at an example. Okay. So these are some important properties that you need to know about FSM. Okay. First property is finite state automata has limited memory. Okay. For this reason, it has to be defined what the machine has to remember and what the machine doesn't have to remember. Okay. And the second important property is finite state automata is the simplest representation of computation. Now let's look at an example. Okay. So let's say this is a button. Okay. An electrical switch button. Okay. When you push it, that is when you give an external input of push, if it is on, it will turn off, correct? And if it is off and you give the input of push, it is going to turn on. Okay. So based on the external input, that is push, the control is going to move from the off state to on state and from the on state to off state. Okay. And the switch has to remember in which state it is. Okay. If it is in on state and if the input is push, then it is going to be changed into the off state. Okay. That's why it's called limited memory. Okay. That it has to remember just the state which it is in and the input that it is getting, and then to which state it has to go after that input. Okay. If it is in off state and you get an input of push, then it has to go into the on state. Okay. Now this was a very simplistic representation of the idea of DFA. Now FSM is categorized in the following categories. There are these categories in the finite state machine. First thing, we have got finite automata with output, and finite automata without output. Okay. So again, we have more categories over here. We have got Mealy machine, Moore machine, DFA, NFA, and ENFA. But right now we are going to learn more about DFA. Starting, we'll do about DFA. Okay. So what is DFA? DFA, also known as Deterministic Finite Automata, consists of the following things: a finite number of states represented with Q, capital Q. Then we have got a finite set of inputs represented with sigma. Then we have a transition function called del. Then we have a start state, that is one of the states in Q. We write it with Q0 because it is the first state, that is starting state. And then we have a set of final states F. Now a final state can be one or more than one. That's why it's called a set of final state. It can be one or more than one. Okay. Now to understand all of this, we have to look at an example. Okay, just let me draw it quickly. A, B, C, and D. Okay, A becomes our starting state. Okay, when you get an input in state A of 0, we go to state C. When you get an input of 1, you go to state B. Clear? Okay. Now when you're in state B, if you get an input of 0, you go to state A. When you get an input of 1, you go to state D. When you are in state C, if you get an input of 0, you go to state D. Okay. And when you get an input of 1, you go to state A. Okay. When you are in state D, when you get an input of 0, you go to state B. And when you are in state D, when you get an input of 1, you go to state C. Okay. Now what is this? First thing you need to understand, A is the starting state, D is the final state. So this is how we represent final state. That is, you have double circle over here. Okay. Now what are these 0, 1 and what are these A, B, C, D? So what is the first thing that we said? That our DFA has? First we have a starting state. Starting state we have got over here. We'll start with the basic thing. We have a starting state and we represent it using Q0. What is the starting state over here? A, correct? Then we have a set of all states that is finite. Okay, I'm just writing it because this is a DFA. So set of all this states that are present in our DFA. So what is the set of all states? We have got over here A, B, C and D. Okay, and how we represent it? We represent it using our capital Q, correct? After that we have got our final state. Okay, so final state. What is the final state? Final state is D. How we represent it? We represent it using capital F over here. Okay, and final state is our state D. We represent it with double circle. And what are the set of inputs? Set of input. How we represent it? We represent it using sigma, correct? So what is set of input over here? It is 0, 1, because these are the inputs 0 and 1, correct? And finally we have got something called as transition function. Transition function. Now what is transition function representation? We use something called as del. Okay, del. Okay, now what is transition function? Transition function is basically if you are in state A and if you get certain input, then in which state you are going to go. That is the representation. Okay, basically transition function is that. Now let's do the transition function for this example. Okay, so let's draw a table over here. Okay, this is our table, and yeah, we have got 2 columns over here. Okay, if the input is 0, then we are going to go in this state. If the input is 1, we are going to in this state. Okay, so starting state A. If you are in state A and you get input 0, you are going to go in state C, correct? If you are in state A and you get an input 1, you are going to go in state B. After that, if you are in state B now, and you get an input 0, you go to state A, correct? And if you get an input 1, you go to state D. What about C? If you are in state C over here, okay, and you get an input of 0, you go to state D. And if you get an input of 1, you go to state A. And what about D? If you are in state D over here and you get an input of 0, you go to state B. And you get an input of 1, you go to state C. So this is our transition function over here. Okay, so I hope you got the basic terminology. First we have got, just let me change the color. First we have got our starting state. You represent it using Q0. What is starting state? A, correct? Because we have marked the arrow over here. Okay, now then we have set of all the states, that is set of finite set of all the states that are present in this DFA, that is A, B, C and D. Okay, and how we represent it? Using capital Q. Then we have got something called as final state. We represent it using F, which is a state D over here, because we have a double circle over here. And then we have set of input, that is what are the inputs over here? External input 0 and 1. So 0, 1, you represent it using sigma. And then finally we have got this our transition function. Okay, so we represent it using del, and this is our transition function, that is based on the external input and the current state, which state we are going to transit into. So this is the transition function. I hope you got the basic concept of DFA clearly. If you have any queries, feel free to ask me in the comment section below. Thank you. So that's it for today, guys. Thank you very much for watching. If you have any queries, feel free to ask them in the comment section below. If you have any suggestions, please write them in the comment section below. If you like the video, please share it with your friends and subscribe to my channel. Thank you very much.